So continuing on with solving systems of equations. So in Algebra 1, Algebra 2, you guys were taught graphing, substitution, elimination is how you solve a system of linear equations. Not too much work. Get y by itself, plug it into the other one, use substitution, use the elimination trick, or graph them. Okay? Once we start getting into 3 dimensions, x, y, and z, it became a little bit more complicated. If you want to solve this system of linear equations, excuse me, not linear anymore, all right, these would be planar, these would be like 3 planes, 3 pieces of paper, okay? If you want to find out where 3 planes intersect, you would have to either use substitution or elimination, and you would probably use an entire sheet of paper to do this problem, okay? And you could easily do it using substitution or elimination. I can't remember the last time I've done one of these using substitution or elimination because it really stinks. Okay? I would use matrices every time because I'll be able to get this done in probably a matter of 5 minutes instead of 35 minutes. Okay? Some of you won't even need to write this part out, but let's say we wanted to change this from a system of equations to a matrix equation. Okay? It would look something like this. 6, -2, 5, -1, 3, 0, 4, 3, 6, times x, y, z equals 12, 9, -8. Because remember how matrix multiplication works, I go across the rows and down the columns. So 6x plus -2y plus 5z has to equal 12, which is exactly what that first equation says. Okay? Why did I put the 0 in the spot I did? Because there's no z's, right? There's -1x plus 3y plus 0z is equal to 9. So make sure you put that placeholder in there. Okay? So some of you will just be able to visualize this by looking at this. Some of you will want to write it out, which is perfectly fine. But all you need to do, call this your matrix A, call this your matrix B, and in order to solve, you're simply going to take what?
Inverse of A times
A inverse times B.
We just have to put that in our calculator.
Use your calculators, get the answer.
I love it.
Okay? I have no idea if this, I just made this problem up, so it might have just awful answers.
Yeah.
Well, might as well just.
Did you?
Yeah, I got 27 point.
So, let me just double check. 6, -2, 5, -1, 3, 0, 4, 3, 6. 12, 9, -8. Math, change to fractions, which will also it'll do for you too. If you don't like those decimals, you can change them all to fractions. Okay. There is an answer to this. Okay. When you do A inverse times B, okay, it's something like 27.6, 12.2, -25.8-ish. You can tell your calculator to change it to fractions for you. And I did that on this calculator that you're seeing on the video, so you can see what your answers are. I clearly just made this problem up, and that's why the answers didn't come out very nice. The previous problem, I calculated what I wanted the answers to be. But do you guys see how much easier it was to use a matrix equation to solve than actually doing substitution or elimination?
Yes.
Okay? So it's something that I kind of like to use. I like to use matrices when I'm solving more complicated systems of equations just because I think it's a lot easier and a lot less time consuming. It's really like using elimination, okay, in a sense, is how it kind of all works, plays out. Or actually, reduced row echelon form is really like elimination, which we're not going to talk about really right now. Okay. But what questions do you guys have on solving systems of equations?
I feel good about